In this lesson, we are going to talk about the core numbers that are found within Python, specifically integers, floating point numbers, and complex numbers. Now, both integers and floating point numbers are actually things that you'll commonly see inside of most languages. And so the fact that you're learning this about Python is actually helpful to you for any type um, of programming language. And so in today, what we're going to talk about is just covering those three types of numbers, how to work with them a little bit and declare them, and exactly what do they mean and how are they necessarily represented. So let's get started in learning about these core numbers. So here I have a bunch of descriptions of what each of these number types are. And it's a lot of words to kind of speak about here. But the big difference between, and I'm going to focus on between integers and floating point numbers, and then we'll get to imaginary numbers here in a little bit. But the difference between an integer and a floating point number is that an integer has no fractional components to it, meaning it's not a decimal number at all. And the advantage of integers is speed. And when I talk about that, everything inside of a computer is a 1 or a 0. It's an on or an off. So integers can be represented using a binary number, and binary numbers are 1 0 0 0 1 0, something like that, right? Or 1 0 1 0 1 0 1 0, like something like that, right? It just a bunch of numbers, whatever, a bunch of ones and zeros all strung together that creates a bigger number. And the way you do that is you take 2 to the whatever position it is, and then add that to your overall number. So for example, if it's just 1, right, it's 2 to the 0, right, plus whatever that number is, and then you add that to all the other ones. If it's 1 0 1 1, so it's going to be 2 to the 0, so that first entry, and then 2 to the 1, that's 2, and then you skip the next one because it's a 0, and then it's 2 to the 3, which is 8. So that number should be 11, right? Because it's 8 plus 2 plus 1. That's in there. So the reason why I bring that up, and you don't really need to know that for any type of specific understanding of what's going on here, but the reason why I bring that up is computers work really, really well when it's just those ones and zeros, and an integer can be easily represented using ones and zeros. The problem is when you get into the really, really big numbers. So the bigger the number, the more bit space it needs to take. So like an int, an int 32, which represents 32 bits or 32 ones and zeros to represent that number, it's quite a large number. But when you start getting to like the billions in there, or even bigger than that, say like you've got like a 10 to the 100 type number. That's a lot of bits that you have to do to represent that. And then even further, if you're working with both negative and positive numbers, well, then that starts shaving off some of those numbers. So if you want something that's going to run fast, but potentially take up a lot of memory, integers are your deal. If you want something that's going to be exact, then integers are what you want to work with. Now, floating point numbers, on the other hand, they have a disadvantage of speed because quite literally the representation requires a calculation. So it's a conversion from these ones and zeros to then a decimal. And because it's a mathematical conversion and it's an algorithm, that representation isn't necessarily exact. So you can't always exactly represent that. So if you remember back in one of our previous lessons, module 2, I believe, where we had 0.1 plus 0.1 plus 0.1 equals 0.3, 0.3 something, right? Well, that's because it's doing a calculation there. And so I want to share with you, well, let's look at that, exactly how that works. So this is what a floating point number is in computers. So you have a 32-bit representation here, and the first 23 bits here is your fraction, and then the second 8 bits, the next 8 bits is your exponent, and then your sign is whether this is a positive or negative number. So what you do is you take -1 to the sign. So if it's -1 to the 0, then it's positive. If it's -1 to the 1, then it's going to be negative. Then you do 2 to the e minus 127, so whatever number this is inside of here, minus 127, times 1 plus the sum of each of these times 2 to the I of that, to the negative I of that. So again, I don't expect you to have this memorized. I don't have this memorized. I use Wikipedia all the time to just kind of remember and refresh myself what this is. But the point and the thing to take away from is that integers are fast, take up a lot of speed, but they're exact. Floats aren't so fast, but can represent a massive amount of numbers. In fact, an infinite number of numbers, if you're willing to take a sacrifice in exactness that's going on there. So let's kind of delve in a little bit how to work with these numbers here. So I've got my my module or my homework repository here. I've created a module 4 in here, and inside of module 4, I'm going to create a file that says numbers.py. And in this numbers.py, remember, we're going to do if dunder name is equal to dunder main. And then we're going to start working with this. So to create an integer is quite simple. You just type in an integer. So age is equal to 32. And ta-da, now you have a way to be able to do that. The other thing that you can do that's kind of interesting is, well, let's just print this out and show you that indeed this is what we expect it to be. Oops. There we go. Numbers.py. We see that, yep, age was definitely 32, value 32, and it is a class of integer. Cool. So that's how that works. The next thing that I want to show you is you can actually take a string and convert it into an integer. And how do you do that? Well, let's just do this. str age is equal to a string of 32, like this. And what you can do actually is cast this. So age is equal to int and then str age, like this. And so what this does is this will convert this value from a string into an integer value in there. So let's print this out. Like this. So here we have this set of code right here. We're going to go ahead and run this. And ta-da, you can see that we got 32 and class of int in there again. So what this did is this actually converted this string over there to that. The other interesting thing about this int casting or int function that's there is you can do other types of representations. So let's say age is written in binary. We're going to do 1, 1, 2, 3, 4, 5. So if I've done this correctly in my head, then that should be 32 that's in there. So age is equal to int of age bin stir. Now, what's different about this is because this is a 1 and a 0 representation, the integer can only be represented in 2 values, 0 and 1. So we're going to throw in there that this is a binary string, or ones and zeros in there. Now let's print out age, and let's print out the type of age in there. Run our case again, and ta-da, there we go. We've got it. The other thing you can do is, it doesn't have to be limited to just binary. You can actually do it in other. So hex is another very common one. And hex, the way it works is you have representations of numbers anywhere from 0 to 9, and then A to F. So there's a total of 16 numbers that you can have in there. So for example, if I have a number that is 8, its representation, it means the number 8. But if I have a number in hex that is the number B, then that number is actually 11, because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, 10, B, 11. So F is actually going to be 15 in there. Now, this is going to be a little bit confusing, but this actually represents 32, because 2 times 16 to the 1 is going to be 2 times 16, which is 32. And so that is what we're going to do. So age is equal to integer of age hex str, and we're going to put in 16, because there's 16 different representations that we can have in there. So let's print age and print that type that's in there again. This should feel somewhat familiar now, and now kind of boring of our output, because quite frankly, it's been the same thing over and over again. 32 and the class int that's in there. So that's how you can kind of work around and work with and create integers. You can use this integer file, or this integer function in there, to talk about, or to convert strings into an integer. You can actually cast that against other things too. So you can actually pass in a float in there. So if you do an int of a float, it converts it into an integer in there. And we'll talk a little bit more about how that works. One little sidebar that I want to share with you in this one is, I've got another video that kind of goes over this, is how to run and debug inside of Visual Studio Code. But I want to kind of show you kind of these representations. So I'm actually going to execute this script in a run and debug using Python file. So what it is, I clicked on this little bug looking thing on side of this play button, then clicked run and debug, and then Python file. Now you notice I clicked over here, this red dot. That's breakpoint. And again, in that video that I'll link somewhere around here, you'll be able to see more details about that. But that breakpoint means stop execution right there. And let's try to examine what's going on. So I'm going to run this file in here. We're going to get to this point right here. And now over here is what I want to show you, is these variables and locals and globals and those types of things. So as we go through and we execute some of these things, we can see over here, age is 32. And what I want to do actually is to do an expression. I'm going to do type of age in here. And then we can see, oh, hey, that's a class of int that's in there. So let's start messing around with this. We see that that doesn't change. But over here, here's str age, right? That's a string of 32. And we're going to keep coming in a little bit further and see what happens. And we have another variable, age bin str, which is the 100,000 text, or 1000000, which represents 32 in binary. We're going to convert that over, and guess what? Age didn't change at all, because it's still 32. So we're going to print that out. And then finally, one more time, age hex str. We can see that over here. So the reason why I pull this up is just kind of show you that there's other ways to inspect instead of necessarily printing this out. As you get further along in your development of your Python programs, having print statements all over the place becomes a little bit kind of tedious and sloppy, to be honest. So what you can do is you can take out these print statements, and then when you need to debug something, you can actually run this debugger. again, I recommend you check out the video that I've already created on how to execute and run things inside of and debug inside of Visual Studio Code, and check that out for more details of that. So let's move on to one more thing. Let's say we've got the number 1 billion in there. Now, 1 billion is a lot of zeros. It's 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? 9, 9, yeah. Man, that's hard to read, right? And oftentimes we're kind of used to, in math, something like this, right? And think that this is going to work. It looks like I misspelled 1 billion. Now, I haven't told you what's going to happen here. I haven't taught you enough to know, but I want you to think about, what will this do when I print 1 billion? What's going to happen in here? Let's see. Let's see what happens. Oops. There we go. It'd help if I was in the right directory. Wait a minute. 1, 0, 0, 0. What is that? Well, what happened there is this is actually a tuple that's in there. And we'll talk about what tuples are, but you can't use a comma to separate numbers. What you can do, though, is underscores, like this. And now that's a little bit easier to read. It will print out what you expect it to be, which is 1 billion. And that's exactly kind of what you want there. So if you want to put a separator inside of your integers, use the underscore, is what you want to do. All right, now let's talk about floats. So a float, very similar to how you do integers, is you just type it in like this. Actually, I'm going to take this away. So age is this, and then I'm going to put down here just print script complete. And let's inspect this using our new little way of debugging things here. So remember, if we click on this little bug looking thing, run and debug, and then run it as a file, we're going to break here, which is a breakpoint that I already added, looks like. But this is actually the breakpoint that I wanted, so let's rerun this. Let's get rid of this breakpoint and rerun this one more time. There we go. Execute this, and let's look over here. Hey, age of that. And type of age is a float that's in there. Cool. All right. So now let's do similar. So we had int, and we could pass in a string like this, right? And we would get an integer in there. Now let's say integer age is equal to float of 32.3, like this. And let's see what happens. So we're going to run and debug this guy. Now we get to line 31. We have not executed line 31. We're going to execute line 31. Okay, it's a float. That's what we expect it to be. And then let's do this again. Hey, it's a float again. And that's exactly what we would want it to be. Even though we passed in a string into this, we expect this to be like that. So there you go. Let's maybe even do it something like this. Age is equal to 32.3. rerun this like this. Okay. Age is now 32.3 and it's a float. Ooh, things changed. And now age is a string with a value of 32.3. Now let's convert that back to a float. Ta-da! There you go. And that's how you do that. So you can do the same thing with floats as you can with integers. So one, you know what? 1,000,000,000 is equal to 1 underscore 123 123 123 dot 0. We're gonna rerun this guy. Come down to this guy, execute it, and now 1,000,000,000 is a float. There you can see 1,000,000,000 is of class float. That's in there. All right, so that's pretty self-explanatory. Now let's talk a little bit about E notation. So what if you wanted to do something even bigger than a billion, right? What if you wanted to do like trillion, right? So it's trillion, that's 12 zeros, right? So 1 trillion. All right, let's see here. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Man, this is crazy. There's another way. Let's do this instead. E to the E9. Print out 1. We're gonna rerun this guy. Step over, step over, step over, step over, and blah. There's 1 trillion in there. E to the, whoops, E should have been E to the 12. There we go. All right, let's stop this. Run as a Python file again. Step over all of these guys, and ta-da, 1 trillion. There we go. So E notation, it's actually something you may have been familiar with from mathematical operations. Essentially, what it means is you are doing 10 to the whatever number. So this 1 e to the 12 is essentially 1 times 10 to the e to the 12, or times 10 to the 12. So if I did 3.14 e to the 12, so that's 3.14 times 10 to the 12. And you can actually go the other way. You can do negative values in there. So really small number. Of course. CD module for Python numbers. And you can see actually it prints out 3.14 e to the negative 12, but it actually is representing it as 3.13 or 0.000000314. That's in there. Okay. Now there is a concept of what's called well, let's see what happens when we go really, really small. Let's see here. What if we did something like this? Too small is equal to 2 e to the negative 400. Let's just say that. And too small. Zero. Ooh. Interesting. Why is that? That's, oh man, that's really small. Let's see about e to the 800. Ooh, that's still printing it out that way. That should be printing, well, let's see here. 2e to the minus 800. Whoops. Nope, if I spelled things correctly. No, it's still 0. So in Python, there is this concept of infinity that's in there. And what that is that's something that's way beyond what that floating point integer can handle. So let's do something ridiculously big or ridiculously small and see if we can trigger that. That value is different for each computer, and I think that's what's happening here. And maybe not. I need to look it up because I am running Python 3.8, and they may have changed things on me. But as there was and used to be this concept of infinity, where things were just too small that it was like negative infinity or too. Oh, you know what? Actually, that is true. And mathematics. So 2e to the minus something, that really, as you get smaller, it really is a 0 that gets in there. As they say, never present live code because you'll inevitably make a mistake. I'm going to keep this in the video because I want to pinpoint and talk about something, and that is making mistakes. And actually, that's an okay thing to do. Making mistakes in programming is something that happens all the time. And be okay with making mistakes. Own up to it and realize, oh man, I made a mistake. And then kind of go on from that. So now let's really talk about something that's too big, right? And that's going to be 2e to the 400. And there we go. Now we have this infinity, this INF that's in there. So what we've done is we've gone so far and so big that we can't represent this number anymore. That's too big for the floating point integer to be able to handle. And you can do it in the other way as well. So, and this is what I was getting confused with, was negative. You can go into the too far in the positive realm, and now you can go too far into the negative realm in there. So let's do this. Boom, now you have negative infinity. So it's not actually infinity. You haven't broken the computational max of something. It's just Python's way of saying, hey, you've gone beyond what Python can now calculate. We're just going to throw infinity or negative infinity in there for that. Now, remember, here's the gotcha that we have with floating point integers that's in there. So let's see here. Float val is equal to 0.1 plus 0.1 plus 0.1 in there. And now we're going to print out float val that's in there. And not only we're going to do that is we're going to run and debug this after we add a breakpoint there as a Python file. And boom, we're going to keep going. And here we go. We hit this. So now this float val, and you can see it's 0.3, a bunch of zeros, and then 4 that's in there. And that's because that float val is somewhat tricky. So because you're doing that calculation that was there, if we go back to here, if you go to this calculation, because of this calculation that's going in there, that's what's happening in there. Okay. So that's it for floating point numbers and integers. The last thing that I just want to introduce you to, that's not necessarily super important, but do want to share with you, is complex numbers. So complex numbers are represented by doing something like this. So my complex is equal to, let's say 2 plus 3j. And now this j, which is the engineering notation of complex complex numbers, the j means that that's your square root of -1 representation right there. And you can work with that. And so I just kind of, again, want to show you that this has some interesting properties to it. So let's see, my complex num dot real, print my complex num dot imag, and then print my complex num dot conjugate. And there we go. You can see that the real part here is a 2.0. That's what we expect. That's what we expected. 3 is your imaginary part, and then its conjugate is 2 minus 3j. That's in there. So there you go. It's able to do some interesting things. So that's the end. We've learned about what exactly is an integer and the advantages of using integers. What exactly is a float, and the advantages or disadvantages that comes with using floating point numbers. And then we briefly touched on how to represent complex numbers and to determine the real, imaginary, and its conjugate in there. So there we go. In the next video, we're going to talk about some more of the mathematical operations that you can do within Python and how to work with these now numbers that's in there. So all we've done is really to kind of represent these numbers, but numbers really isn't that interesting until you start working with it. So let's start actually doing some interesting things with these numbers in the next video.